Alright, now for the last few bits about some lines and circles. I've drawn our old friend circle C, and now we're going to look at a different type of line. We've talked about radii, diameters, and tangent lines. Now we're going to look at something called a chord. And all a chord is any line that connects 2 points on the circle. So we'll name these points A and B. Segment AB would be called a chord because it connects points on the circle. That's the end of that sentence. I should have just stopped there. So let's get a definition for that. A chord, any segment that connects 2 points on a circle. Now, interestingly enough, we've already talked about a certain type of chord. If you think about a diameter, it connects 2 points that are on the circle, but passes through the center. So a diameter is really just a special case of a chord. It's a chord that passes through the center of the circle. Alright, so that's a chord, just any point connecting those two. We give a chord a special name if it passes through the center. We call it a diameter. But other than that, that's pretty much all there is. So let's talk about some of the more interesting aspects of a chord. And let's take, just for argument's sake, and draw a radius. So we'll draw a radius CD, but I've drawn this in such a way that CD will be perpendicular to AB. So now I've got a radius and a chord that are perpendicular to each other. If you have this situation, what happens is that the chord will be bisected. So again, if the radius and the chord are perpendicular, the chord gets bisected, so segment AE would be congruent to segment EB. And I'll just put that into words over here. If a radius is perpendicular to a chord, the radius bisects that chord. And this works the other way as well. If we take the converse of this, we can say that if we have a chord that is bisected, the radius must be perpendicular to it. So there's fact number one about chords, that if you have a radius that is perpendicular to that, it's going to bisect the chord. The second one has to do, well, let's draw another. There's a lot of these that are just much easier to see with pictures. So let's see them in pictures. Draw another circle very quickly here. Oh no. Alright, so there is an approximate circle. We'll call this circle S. Now let's take a situation where we have chords like this. So I have two sets of chords. I'll name them so that we can talk about them more easily. Let's say this is chord AB and chord CD. What we can say is that if chord AB is a certain distance away, and we measure that distance by doing a perpendicular line from the center. So if it's a certain distance away from the center point, and this one is the same distance away from the center point, that is if we draw a line perpendicular to it, and if we can say that those two are congruent, that means these chords are the same distance from the center of the circle. When this happens, then these chords must be congruent. So over here I can say that chord AB is congruent to chord CD because they are the same distance from the center. And again, this is true anytime you see this. If you have two chords that are the same distance from the center of the circle, those chords must be congruent. All right, and our last bit of interesting chordness comes from what happens when you have chords that overlap inside the center of the circle. So I'm just going to draw two sets of chords like this. And what I can say is that when I have this situation, two chords intersect inside the circle, I can say that these sides are proportional to each other. And the reason I can say that is this, is that if I connect down here, like let's say with a dashed line, and then I connect here with a dashed line. So what I've done is I've connected those points where they touch the circle. What I've done is create two similar triangles. So what that means is that since this triangle is similar to this triangle, you're going to have these sides be proportional to each other. Now I'm just going to give these sides names for convenience sake. And the relationship, if you want a very easy way to remember this, since the long side is proportional to the small side for both chords, the easy way to remember this is to say that the long side of a chord times the short side of a chord is going to equal, well, the short side of the chord times the long side of the chord. So again, this times this should be equal to this times this. And this will allow you to find various segment lengths within the circle.